and doing good. And in this video we will see quick sort. In this series we are going to cover recursion, and this is the last video for the recursion, and with the help of recursion we will see the quick sort, right? Basically quick sort is based on divide and conquer technique. Divide and conquer technique, okay? And in this there is a basically funda of the quick sort, that partitioning. Suppose there is a given array, okay, and this array, suppose there is a something element here, and this array should be partitioned into two halves, okay, where a element which we have selected, that element should be set as a appropriate place, okay. Suppose that there is this is the array, and this array should be divided into two parts, and there is a element. This element is set as a appropriate place, means this is a we consider there a element as a pivot element, which element as a pivot element we will consider. We can take any element from the whole array, other left part, other right part, yeah, other middle parts, yeah, other any element we can take. And this element which we have taken up as a pivot element, this should be at the first, it will be go at the appropriate place, okay. And again, already know about the functions and advantages of the recursion. Means when we have solved a big problem into a small problem, we divide it into a small problems, then recursion will be automatically conduct it, and automatically it will be solve this, okay. If we are divided into and one part has been set as appropriate place, and again we have called these functions and this array, then it will be also divided into, and their element as a element should be set as an appropriate place, and also this will be set as appropriate place, and according to this scenario recursion will be solve this approach. There is a basic, okay. Now we will trace the full code, okay. Let's try to understand first. Okay, there is a given array, and suppose there is a any elements are given which is a unsorted order, okay. First list 5, 7, 3, 2, 10 and 11. This is the unsorted order, and the first condition is to set a two variable as a first a lower and second is a upper bound, lower bound, upper bound, start, end, what you want you can take, okay. I will set here lower bound and there is a upper bound, okay. Now, and the second condition is to set a variable as a pivot element, okay. Now here we can set at the pivot element in a lower bound, okay. Now this is the pivot element, means as lower bound is indicating at the index of 0, 1, 2, 3, 4 and 5, and upper bound is indicating at the last of the array. Now the first condition should be, will check with the help comparison with the help of pivot element and lower bound, okay. And also we'll compare with the pivot element and the upper bound element. When we are comparing with the help of lower bound, then it should make sure that the element of the lower bound should be less than. When it should be greater than, then we'll not remove it, will not go ahead, yeah, or not increment this lower bound, Okay, if greater number is the 1, and if when we are comparing with the help of upper bound, then it makes sure that the element should be smallest. If number is smallest, then we'll something do. What will we do? Now here we will see. First of all, we have a lower bound is 5 and pivot element is also 5. Then go on the lower bound here, and also compare with 5 and 11. Yes, 11 is greater than the 5, then upper bound should be decrement. Okay, upper bound is indicating here. Okay, now again check the 5. 5 is less than 5 is yeah, 5 is 7 is greater than the 5. Yes, 7 is greater than 5, then no need to increment it. Now again check it. 5 is greater than 10 is greater than 5. Yes, 10 is greater than 5. Now it should be decrement, and here is upper bound. Now again check, it will be 7. No, there is no need to increment, and 5, and there is a 2. 2 is the smallest, smallest than the 5. Yes. Now at this point what will we do? 2 and 7, lower bound and upper bound, means at this time it's that array should be here 5, 7, okay, 3, 2 and 10 and 11. Now this should be swapped. Okay, now it should be 2 and it should be 7. Now here is our upper bound, and here is our lower bound and upper bound, and also we have the pivot element. It's the 5. Again it will be check, it is a less than. Yes, it is less than. Now at this time lower bound should be increment, and here it will be checked is a greater than. Yes, it's a greater than. Now at this time it will be increment. Okay, now here it will be again check that 5 is less than. Just 5, 5 is greater than the lower bound. Yes, 5 is greater than the lower bound, then at this time no need to here. No, sorry, it will be now here it will be increment, and it should be lower bound, and also it here is a upper bound. Okay, again it will be checked, and 5 is 7 is less than or greater than. 7 is greater than the 5, then lower bound should, lower bound it will be here, and it will be checked 5 is with the help upper bound. Now it will be checked, then upper bound should be decrement, and it will be upper bound here. Now we will stop when the upper bound and lower bound is crossed to each other. That time we will be stop, and now at this time what should we have to do? We have to do the with swapped with the upper bound. Okay, now at this time there is a divided into two halves, and 5 will be swapped at the 3, and this will be 2 and 3. Sorry, it should be 3 and 2, and this is the 7, 10 and 11. Now at this time all the element sorry, it's this pivot element is guarantees that all the element of the left side will be smallest element, and all the element of the right side is a greater element. Now here we can see the all the element of the right side 5, 3 and 2 is less than the 5, less than the pivot element, not 5, less than the pivot element. And on the right side we can see all the element of the right side is greater than the pivot element. It's a make sure pivot element. And now it's recursively it will be called here. Now set a pivot element and lower bound and upper bound. Again recursively we can call it that lower bound upper bound. It will be recursion functions will be automatically conduct it. No need to there is no more problems. Recursion functions will automatically conduct it. Now there is a main funda of the partitioning. Now we'll write the code, and with the help of code we will trace it. Now okay, there is a first condition. There was the while their first condition was while lower bound is if lower bound element is greater than, okay, lower bound is greater than, okay, pivot element. With the pivot element, then no need to increment. If less than, then we have increment. Okay, achha, directly we can see here, if lower bound is less than the pivot element, then increment lower bound increment. And okay, now second things, while if upper bound is greater than the pivot element, that time upper bound should be increment. Okay, and this process is going to this process when it should be stopped, that time while if lower bound is crossed to upper bound, means lower bound is less than the upper bound, that time at this function should be working. Okay, when this condition is satisfied, this both condition is satisfied and this should be satisfied, this while loop condition, then what should we have to do? We have to swap this lower bound and upper bound. Okay, now swap lower bound and upper bound. When upper bound and lower bound is swapped, then that time when it will be crossed, then we have to swap, sorry, it will be swapped under the while loop, then swap lower bound and upper bound. And after this loop, when it will be crossed, that time we have to swap with the help of, because both elements should be lower bound and upper bound should be point element which should be where pivot element should be appropriate place. Now then we can swap after this loop lower bound, yeah, upper bound and pivot element. Okay, and pivot element should be returned, pivot should be returned as a partition element. And I will write the complete code on our machine. Now here lower bound is less than, here we can see the lower bound is less than the upper bound, at that time we are going to increment or decrement, and this condition is satisfied. This condition is satisfied that this time lower bound should be increment and upper bound, when upper bound is greater than the pivot element, then we are going to decrement. And after this lower bound and upper bound is going to swap, upper bound and lower bound is going to swap, and when it will be swapped, then pivot element and both locations lower bound and upper bound location is the same, then we can swap as a lower bound and the pivot element. This is the basically about quicksort, and I will write the complete code on my machines. Let's code. We see the approach of the quicksort, and here already I have written the main functions, and there is a given array and the size has been calculated. After the size, this quicksort function has been called. Okay, now this function has been called here, quicksort, and array has been passed, and there is a lower bound and upper bound has been passed. Okay, and this if condition is satisfied, because it is a recursive functions, then there should be a base condition is mandatory. So then base condition is lower bound is less than the upper bound. Okay, now we see the partition, and this is the main things in the quicksort, and we have to write for this code, and then recursive function will be automatically conduct and solve this all the small problem. First of all, we have to only solve a single part of the problem, and the recursive function will be solve all the problem. Now here, let's run for this the part, write the code for the partition. Okay, now it should be an integer type, because it is a passing any value, and it is the array, and this is the also lower bound, and this is the upper bound. Okay, and this is the function. Okay, done. When this function will be, when first of all set as a pivot element as a array of lower bound. Array of lower bound has been okay. Now now set as a start as the lower bound, and also end maximum value, and set as a upper bound, and this should be when a start is end, that time. Okay, now again check, it will be again check that the array of a start is greater than the pivot element that time only start plus plus. Okay, and if while array of end is greater than the pivot element that time end minus minus. When this both condition is satisfied, and if uh, start is less than the end, that time we have to swap the swapped array of start and array of end. Okay, and after this, when this one, then swap what array of end and the pivot element. Okay, we can take here both array of end or array of, because now we have to write and also return and return end. Okay, now write the code for this functions here. Now let's go here, and after here, okay, void, and we have to taking a two variable here, then we have to swap two variables. Now we have passed the reference of this then num1 and also a reference of the number 2. Okay, now swapping int temp num1, and in num1 we have passed num2. Okay, and num2 we have to pass temp. Now let's run the code, and here we can see the sorting data after the quick sort 1 2 3 4 5 6 7, and this data has been sorted in ascending order. And now this code will be available on GitHub, and go and visit, and like, share, and comment.